Hello, everyone. An essential step in engineering design process is to generate as many as possible concepts or ideas or solution to a problem. We said we start with defining a problem, which it comes from a need, and then we carefully provide the details by defining the problem. And then we move on to the next step, which we're going to talk today on common methods for generating conceptual designs and solutions to a problem. But before we get to that, I'm going to talk a little bit about creativity. In particular, are there special people who are born naturally creative, or can this skill be developed by anybody? Well, who is a creative and a problem solver? We can say a creative person is somebody who can combine ideas or who can get a fresh perspective on a new idea or make connections to unrelated ideas. Look at the example of Velcro or the example of post-it notes. And I'm going to leave it to you to read more about them if you haven't heard about these stories. Um, but we should keep in mind that they are not just sudden inspiration, like creativity. It starts with an imperfect or incomplete idea, and then we slowly develop it over time. To develop creativity, first we have to have a positive attitude, have the confidence that we can be creative. And as a tool, we can rely on our imagination, our childhood imagination. That's a powerful tool. And of course, it requires hard work, so we need to be persistent. Well, we can say there are four stages uh, of creative thinking process. This is just one model, of course. We start with defining the problem, and then we let the problem to sink in, and we perhaps get inspired, and a solution uh, comes up, and then we check the solution with the desired result. Uh, There are some barriers to creative thinking. The main one are the perceptual blocks, and it comes from lack of knowledge or not properly defining a problem. Emotional blocks, like fear of risk, lack of motivation, or being uncomfortable with unstructured situations. And intellectual blocks, which mainly when we lack a background or knowledge related to that particular problem. So we can say then these three main blocks: perceptual blocks, not properly defining a problem, being not being a risk taker or uncomfortable with chaos or unstructured situation, lack of motivation, or inadequate knowledge or background can be the main barriers of creative thinking. Let's just look at the perceptual blocks. So, stereotyping, like having a belief that a certain person or a certain event cannot do something, being overloaded with the details, uh, or limiting the problem with many constraints, fixation to a particular solution, or being primed by, let's say, an example or a solution to a problem. So, in other words, let's say if I have the belief that heavier than air machines cannot fly, so perhaps then I cannot go and invent something that can fly, right? If we overload ourselves with the details, then we cannot look at the big picture. So always start with the broad statements of a problem and avoid fixation. Let's say for a particular problem, you fix on a particular solution and you don't let your mind to come up with any new idea. And priming is the same as fixation. When you are exposed to an example or a solution and your mind is fixated to that examples. Now I'm going to talk a little bit about the common methods for generating ideas. The first one is the 635 method. Here, the first number is the size of a team. So it doesn't have to be 6. A team can be 5, 4, or 10 members, but 6 is an ideal numbers. So I call it the X35 methods. How does it work? Well, the team members gather around the table, and each member is going to have a sheet of paper, and you draw 3 columns on it. Then each member is going to have, they're going to come up with 3 ideas, which either write it or draw a quick sketch on the top. Like we may allocate 5 minutes. So the number 3 here, the second number is then the number of columns that you draw, and 5 is the 5 minutes. So after 5 minutes, each person pass their paper to the person sitting right to them. And then each member now look at the 3 solutions which came up with the person next to them without any judgment or laughing or any saying anything. And they look at the solution, and then they come up with 3 new solutions and pass it to the next person. So it goes around after the sheets have been passed to all members. Then after that, we have produced many solutions. So we're going to discuss the solutions and narrow down the solutions and find out the best solution, actually. I'm going to leave it to you. Maybe you can pause the video and with your team or other groups, come up with a solution to this problem. Basically, a phone holder in an airplane. You can read the problems and use this method and see how many solutions you can come up with. And then discuss with the team the number of concepts you came up, the quality of concepts, and so on. The second method is the morphological chart method. Well, the objective here is to generate concept designs or ideas. The steps for this method is first break down the system that you're dealing with to sub-functions. And then you need to come up with different methods to actually accomplish each of these functions or sub-functions. Now you have a chart containing the many solutions for sub-functions, and now you can mix and match a combination of them. Let's provide you with an example. Let's say we want to design a modern forklift. So we break down the functions, the main function of these forklift to its sub-functions. So these are the sub-functions. Any forklift needs a support, like the main machine needs a support. It can be on a wheel, on a rail or something. And then we need propulsion for this system. How the forklift can actually move around. It requires power to lift, of course, transmission, steering, stopping, lifting, and operator. You may come up with more sub-functions, but let's just keep it simple for now. Now I want you to pause the video, and for each of these sub-functions, come up with means that we can accomplish these sub-functions. For example, for support, means can be wheels. So the forklift can sit on wheels, on track, on air cushion. It can slide, or it can have legs and feet. Yes, there is nothing wrong to have a forklift or next generation of forklift that has legs and feet. All right, so I want you to pause the video and come up with actually different solutions or means for each of these sub-functions. Right? Now let's review my solution and compare with yours. So for propulsion, I may suggest we can have driven wheels, we may have air thrust, moving cables, or linear induction. For power, it can be electric, gasoline, propane, nuclear, or solar. For transmission and steering, well, we can use gears, belt, chains, and so on. And for stopping, we may come up with friction, let's say reverse thrust, ratchet, electromagnetic brake. Similarly, for lifting, maybe we can use hydraulic, screw, chain, or other methods. And eventually for operating the system, for the operator, it can be seated, it can be a standing, walking, remote control. Right? Now, after we come up with that, now we can mix and match. Remember, our goal here is to accomplish all these sub functions and combine them. So for example, I may, for the support, maybe I choose wheel, then I move on for propulsion, maybe I choose moving cables. For the power, maybe I use propane as the fuel or energy for the system, and so on. So we can have different, of course, combination. Let's say here, the red is one concept. I use wheels for the support, then for propulsion, I use air thrust. For power, I use propane. Transmission, I use belt, and so on. Concept B, the green one, is going to be on air cushion. Our forklift is going to be on air cushion. We're going to use moving cables, gasoline for the fuel or power, and so on. And concept C is the blue one, as you can see the combination. So as you see, you can now have many, many combinations, and then you need to narrow down your list, which is our next discussion. What is the best way to narrow down our choices to get to the best solutions? So the conceptual designs can be in a form of words, but the best is to use sketches. And sometimes we may use simple 3D models. But starting with a sketch, like this example that I show, is a good point to communicate your concept or your idea and your solution to your teammates. Keep in mind, if you're generating one idea, most likely is a bad idea. But if you generate 20 ideas, there might be a good one between these 20 ideas. So the goal here for your capstone design with your team to come up with many ideas. Please use one of these two methods, either the 6-3-5 methods or the morphological chart, or maybe both methods, and come up with at least 20 ideas. Let's summarize. A concept is basically an idea, a solution to a problem, an incomplete solution. The goal to come up with many concepts. Here we set a moderate number of 20 ideas. Common methods, 6-3-5 method, or the morphological chart. So work individually and with your team, and then evaluate your solutions. And of course, the concepts can be in a form of words, but better is to have them in a form of sketches. You can draw your sketches when you work individually or with your team in your logbook, engineering logbook, or sometimes maybe we just use simple 3D models to communicate our solution, not detailed 3D models, but a general 3D models. Thank you very much for listening, and see you next lecture.